Hello everyone, my name is Yamil Guevara. This is the third video on a video series about machine learning logarithms. In this video, we are going to be covering logistic regression. However, before we actually cover logistic regression, let's discuss the data set that we are going to be using in this video. So, we will use a telecommunications dataset for predicting customer churn. This is a historical dataset where each row represents one customer. The data is relatively easy to understand. You may uncover insight you can immediately use. Typically, it is less expensive to keep customers than to acquire new ones. So the focus of this analysis is to predict the customers who will stay with the company. This data set provides information to help you predict what behavior will help you retain the customers. You can analyze all relevant customer data and develop focused customer retention programs. Now, let's discuss what's included and what kind of information is actually included in this data set. Well, the following information is included. Customer who left within the last month, the column is called churn. Services that customer has signed up for instance, phone, multiple lines, internet, online security, online backup, device protection, tech support, and streaming TV and movies. Customer account information, how long had they been a customer, contract, payment method, paperless billing, monthly charges, and total charges. And of course, it includes demographic information about the customer, gender, age range, and things like that. So now that we discussed that data set and what we are trying to accomplish, it is time to do what we always do when we build a machine learning model, and is to import our libraries. So let's do that. So we are going to be using pandas. So we're going to import pandas as PD. We're going to be importing PyLab as PL. We are going to be importing NumPy as NP. We are going to be importing SciPy as T. We are going to be importing from scikit-learn preprocessing. Preprocessing. And of course, since we're using Jupyter Lab, we have to use MATLAB, matplotlib, inline. And we're going to be importing matplotlib, pyplot as PLT. So let me see, everything looks good. So let's run this code. Okay, no problem. So the first step in creating any machine learning algorithm is to import the libraries that we are going to be using. So we just did that. So now it's time to actually import our, our data set. So let's do that right now. Okay, so now we need to import our data set. So I'm going to import our data set and save it under the variable called churn df. df stands for data frame. So churn df. Churn, sorry, I spelled church. Churn df. Churn df. Okay. We're going to use Panda to import our data set. We're going to read it. Read C. Yes. going to be churn data CSV. And of course, I always like to look at my data, the first 4 rows in my data set. So I'm gonna, and this will show us the fourth row of our data set. Let's run this code. Okay, so here's our data set. We have several independent variables. Got tenure, age, address, income, education, employment, and things like that. And of course, here our target variable here, a target vector called churn. One means that the customer left left our company. 0, that means that customer got retained. So the customer, we were able to retain the customer. 1 means that, once again, 1 means that customer left. 0 means that customer was retained. So we want to predict the customers that actually left and the customers that were retained. That's the purpose of this exercise, to make predictions based on the independent variables. So now that we have imported our libraries, we have imported our data set, it's time to do some pre-processing and selection of our data. Okay, so let's select some features for our modeling. And we also need to change the target data type to be an integer, since it is a requirement by the scikit-learn algorithm. So that's what I'm going to do right now. So let's do this. Churn df. Churn df. So let's select our features. Tenure. Remember, these features are the ones are our independent variables. They are the ones that will be explaining our dependent variable. Okay. And our dependent variable is the target vector called churn. We will do that. We will select that very soon. As type, integer, right? It's going to be converted to integer type. And of course, as always, I always like to look at my data. I like to look at the first four rows in my data set. Okay, so let's run our code. Okay, so there was some type of error here. Let's see. And it says cannot assign to literal. So let me see. Churn df. Churn df. Correct. All right, so that's gonna become an integer, and we're gonna save the new one into churn_df, into a new churn_df variable. So let's run this code. Okay. Okay, so far so good. So it actually worked out. So we were able to transform our churn_df into an integer because it is a requirement by the scikit-learn logarithm. And we did this by typing as type integer. And of course, we actually printed our data to look at the first 4 rows of our data set. And here's our first 4 rows of our data set. So we selected the features that we're going to be selecting, okay? We're going to be using for this model. And we deselected the other ones. We didn't select the rest of the features. Remember that we had a lot of independent variables here, a lot of them, but we selected just the few for our model. Okay, so let's continue. So now it's time to define our x, our independent variables, and our y, which is our dependent variable. So let's define our independent variables. We're going to use numpy to select our independent variable. So these are our independent variables. So these are independent variables. Our independent variable are tenure, age, address, income, education, employment, and equipment. So these are going to be our predictor variables. They're the ones that are going to be predicting the churn, whether or not the customer will leave the company or not leave the company. And as always, I always like to see my data set. So this is going to show me my data set. So let's run this code. And here we are. That's our data set. So far, so good. Now let's define our dependent variable. And our dependent variable is what's going to be explained by the independent variables. So our dependent variable is y. We're going to use numpy. And as always, I like to look at my data set. So our dependent variable is the target vector called churn, which shows which customers left the company and which customers were retained by the company in the last month. Let's run this code. Okay, excellent. So far, so good. So far, let's have a summary of what we have accomplished so far. We have imported our libraries. We have imported a data set. We have selected our features. We have selected our independent variables, and we selected our dependent variable. Now it's time to normalize our data set. So let's normalize our data set using scikit-learn preprocessing. So let's do that. Excellent. Preprocessing, standard scalar, fit, transform. And as always, I always like to look at my data set. Okay, so we're going to be transforming our data set to normalize it. So far, so good. So we've done an amazing job. It has worked. So everything has gone as planned. So now that we have normalized our data set, it's time to split our data set into train and test sets. So let's do that. Let's split our data set into the train and test set. So we're going to be using scikit-learn. Okay, sklearn, model selection. Okay, so let me explain what's going on here. So 20% of our data set is going to be used to test our model, and 80% is going to be used to train our model. Okay, that's what this means. Our random state is 4. This means that if you want to get the same results that I'm going to be getting, you must set your random state to 4. If you set your random state to any other number other than 4, your results will be different. That's what this means. So let's continue. Okay, so let's run this code. Okay, so far so good. We have selected our data set and everything's gone as planned. Remember, 20% of data set is going to be used to test the model and 80% will be used to train the model. So let's continue. So far we have split the data set. We have selected we selected about 20% for testing and 80% for training. Now it's time to create the model. So let's build our model using the logistic regression from scikit-learn package. This function implements logistic regression and can use different numerical optimizer to find the parameters. Now, this version of logistic regression in scikit-learn supports regularization. Regularization is a technique used to solve the overfitting problem of machine learning models. The C parameter indicates inverse of regularization strength, which must be a positive float. Smaller values specify stronger regularization. Now let's find our model with the training set. Okay, so let's begin our journey. Let's continue our journey. So we're gonna be using scikit-learn to build our model. So we are going to be using a training set to build our model. Okay. Okay, so we are gonna be using scikit-learn logistic regression package. Okay, so let's run this code. Okay, excellent. So far, so good. Now that we have built the model, now it's time to make predictions. Remember, the whole point of this exercise is to predict whether or not a customer is gonna be leaving the company or if they're gonna be staying with the company. So let's make that prediction right now using the model. Predict function, predict, and of course it's going to be a test set. And as always, I always like to look at my data. And that's what this will do. It will show us our prediction. Let's run this. And here are predictions, okay? So we got all these customers who are gonna be staying with the company, 0000. There's this customer who's gonna be leaving. These are gonna be staying. These are gonna be leaving, staying, leaving. I know, yeah, leaving, staying, and so forth. So we made our predictions. So we have accomplished what we set out to accomplish. Now that we have built our model and we make predictions, now it's time to actually evaluate our model. In order to evaluate our model, let's try the JACAR index for accuracy evaluation. We can define the JACAR as the size of the intersection divided by the size of the union of the two label sets. If the entire set of predicted labels, for example, strictly match with a true set of labels, then the subset accuracy is 1. Otherwise, it is 0. So a JACAR index of 1 is better than a JACAR index of 0. So we are looking for a JACAR index of 1. Okay? So we want a JACAR index of 1. That's what we're looking for. So let's calculate our JACAR index. So from scikit-learn matrix, import JACAR score. Okay, let's calculate a JACAR score and let's run it. Okay, here's our JACAR score. We got a 0.7. So this is actually a pretty good model. So 70% is actually accounted for. Excellent. So we have got a pretty good model. Now let's do one last thing. Let's do one last evaluation. Now let's try the log loss for evaluation. Uh, in logistic regression, the output can be the probability of a customer churn is yes or equal to 1. This probability is a value between 0 and 1. The log loss or the logarithmic loss measures the performance of a classifier where the predicted output is a probability value between 0 and 1. Now, the log loss uh, evaluation or score is actually uh, different than the JACAR value or the JACAR score index. In the log loss of 0 is actually preferable than a log loss of 1. So we're looking for a log loss of 0 and not 1, okay? Which is the opposite of the JACAR index, where we're looking for a JACAR index of 1. So let's do this. So let's calculate our log loss, okay? So sklearn matrix import log loss log loss y test y hat probability. Okay, let's run this code. Okay, so there was a problem. Y hat is not defined. Okay, so I made a mistake here. Y hat. Okay. It seems like I haven't defined my Y hat. Give me a second. I think I haven't defined my Y hat, even though I thought I had defined it. Probability. Yes, I need to define my Y hat. So let me see. Okay. So let me define my Y hat. Okay, so that was a problem. I made a mistake. So let me define that. So my Y hat probability equals LR dot predict probability X test. Okay. So that will solve my problem because I had not defined my Y hat probability. So I just did it. I just defined my Y hat probability. Let's run the code. Oh, there it is, zero point 0.6. Remember that in log loss, we're looking for a number that is actually closer to zero and not closer to one. So this is actually pretty good. So the Jacquard index of one, and we're looking for a Jacquard index of one, and we had a Jacquard index of 0.7. We're looking for a log loss of zero, and we got a log loss of zero point 0.6, which is pretty much equivalent. So far we have a good model. So that's the end of this video lesson. So in this video lesson, let's okay, seems like this video lesson. Give me a second. Seems like we found we create a model. Uh, we covered the logistic regression. Now, if you like this video, please hit like, subscribe to the channel, and leave some comments in the section below. I wish you all the very best. Take care.